Just our project is Shortbread. It is a self-diagnosing breadboard. Our team of 5 members that you see on this slide. Michael Caro is our lead embedded systems engineer. Tomas Contes is our lead firmware engineer and documentation coordinator.
Hyujin Chung is the lead test engineer and webmaster. Kyungchul Ha is the lead schematic and layout designer. Christopher Tia is the lead manufacturing and expo coordinator.
The motivation behind Shortbread is that many of the existing breadboards that we use lack safety features. You just plug and play, you just build a circuit on it, power it, and hope it works. But because many of the electronic components you put on breadboards have exposed leads, they can cause short circuits if they're placed in the wrong places. And the circuit topologies that people build on breadboards can be complex. So debugging these breadboard circuits can become tedious and frustrating, as it's hard to visually go through each node and figure out which is connected to which, as shown in the photo below.
So the intended use for Shortbread is to mainly prototype and debug circuits. The main audience would be university electronic lab courses instructor for their own courses, and potentially electronic hobbyists and maker spaces. The Shortbread will be able to plug into the lab supply and work under the standard lab safety precautions. The product functionality would consist of a short circuit pre-check with combinatorial testing and LEDs. And also it will have a way to circuit break when there are faults.
As you can see in this slide, we're going to show you what a traditional breadboard looks like. It has each row connected with a metal strip. The rows represent circuit nodes. The standard size of a breadboard is usually 2 columns, 30 rows, and 5 holes on each row. So in the middle, you're going to have some enough spacing for dip ICs, and each power rail has a plus to minus voltage supply thing that connects to the columns.
So these are the core functionalities of the Shortbread. So there is an idle state where no checks are done and user can work on building and connecting the circuit. And then it goes to the pre-check mode where user has the built circuit, and then no power is supplied to the circuit. And then that way the Shortbread can detect and alert for any short or open connections. Then once the pre-check is done, it goes back to idle and does the run mode where the circuit is powered and the Shortbread monitors for dangerous current surges. And finally, if there is a current surge, then it goes to the fault mode where there's dangerous current that is detected and it forces the power supply to shut off.
So as you can see in figure 2 on the poster, this is what we have built. This is what Shortbread looks like after building the prototype. So the user interface is simply a very alert design. So you have LEDs along each of these rows that indicate which row is being connected to where along power-wise. Then you have push buttons to transition between the run and the pre-check modes. And then the standard size of the traditional breadboard carries on with this design, as you have the standard body with the rows and enough spacing in the middle for the dip ICs. And then you have also banana jacks on top to allow for connection to an external power supply to power any circuits. Underneath the hood of this machine is an Arduino microcontroller that can do all the checking to make sure which connection is being shorted, open, and etc. So it is an intuitive and simple design that any user should be able to use immediately.
When doing performance checking for the prototype, we successfully confirmed that the pre-check mode works and color codes the LED associated with the nodes used by the circuit. And however, when doing the run mode, when connecting to the power supplies, we were unsuccessful in achieving the run mode.
So for user steps, it's very simple. 1, the user builds the circuit and modifies it. 2, the user either presses the pre-check or run mode button. If they press the pre-check button, the LEDs will light up as Shortbread determines which node is being connected to where. If they run the run mode, power from the external supply is used to power on the circuit, and any dangerous current surges will be shut off. But in the end, if any faults are detected in either run or pre-check mode, it will lead us to all the LEDs alerting the user to, hey, there's a fault, and it goes alert the user that they need to re-modify their circuit. So future improvements wise, we want to make this board shorter. We want to make Shortbread smaller, So that means decreasing the size of PCB, and that includes also making the circuit breaker IC a standalone chip put on this board instead of being hooked up to a second development board. So going forward, Tomas contest will demonstrate you a live demo of our product.
So here's our prototype of our product, the Shortbread. So you can see here the users made a bunch of different connections to different power rails. The red is the plus power rail, the middle rail is the minus power rail, and then we have the ground power rail. And in order to see which nodes are connected to which rails, we're going to press this pre-check button. And now the LEDs will light up based on which rail it's connected to. So here we have a red LED, which indicates that this node here is connected to the plus rail, and the green LEDs indicate that these nodes are connected to the ground rail, and then this LED indicates that this node is connected to the minus power rail. We also have a feature that if a user were to make a connection from a node to two different power rails simultaneously, let's rerun the pre-check. And it does nothing, apparently. Hold on, folks. There we go. Then it alternates colors. So here we see that this node is connected to the plus rail and the minus rail simultaneously. You will also note that this LED flashes because the rails are essentially shorted together. So it affects any nodes connected to either the plus or minus rail. And that's it for now.